Good morning, students. Today we learn how to calculate weights using the perceptron network for and-not function when all the inputs are presented only one time. So here we take the bipolar inputs and targets for calculating the and-not function for the perceptron use. Fine. Okay. So next, first of all, we calculate the truth table for the and-not function. This is very important for the and-not function. How to calculate the truth table. In the perceptron network, which use perceptron learning rule is used to train the and-not function. Okay. Now, the basic important thing is that here we consider two input, that is x1 and x2 are two different inputs. Fine. So the pattern will be, we know that is 1 0 1 0, and here 1 1 0 0, and 0 is replaced with -1 for the bipolar inputs. So what will be the target now? What will be the inputs combinations now? That is 1 -1 1 -1 and 1 1 -1 -1. Okay. So the most important thing here, the target will be 1 when input pattern will be 1 and -1. That is, here we just see that here the x1 value is 1 and x2 value is also -1. Therefore the target will be 1. And in all the cases when it is 1 1, when it is -1 1, and when it is -1 -1, then the target will be -1 -1 -1. Means except the 1 and -1 concept, all the target will be -1. So this is very important. Target will be 1 when the input value will be 1 and -1 for and-not function. Otherwise, this will be 1. Fine. So here we considering, that is the weight. First of all, here we considering the weight, that is W1, W2, and B. All are 0. And here theta also a threshold, that also 0 initially. And the learning rate, that is alpha, is set to 1 over here. Okay. So this is the truth table for the and-not function. Next, the network for the and-not function, that is here we considering x1 and x2 as the input and B is the bipolar target. Fine. So that is the B, and this is the output, final output Y, and this is the Y in. So this is the input of x1 and this is the weight of x1, this is the input of x2 and this is the weight for W2, and B, the weight for B is B. Fine. So x1 W1, x2 W2, and B are all we require for calculating the Y function. Next, for the first input pattern, that is x1 is equal to 1 and x2 is equal to 1. If we consider the truth table, that is x1 is equal to 1 and x2 is equal to 1 for the first input pattern. Therefore, first we consider x1 is equal to 1 and x2 is equal to 1 with the weights and bias, that is W1 is equal to 0, W2 is equal to 0, and B is equal to 0 initially. Because initially we treat W1, W2, and B all are 0. Okay. So calculate the net input. We know the formula, that is y is equal to b plus x1 w1 plus x2 w2. So b is equal to 0, x1 is equal to 1, and w1 is equal to 0, x2 is equal to 1, and w2 is equal to 0. So ultimately y value is 0. So this for the first input pattern. Y value is 0. So the output y is computed by applying the activation over the net input calculated. That is how to calculate the output y. Now we calculate the first we calculate the y from this formula, that is b plus x1 w1 plus x2 w2. Calculate first y in. Okay. Next, so we calculate first y in. Then if the value is 1, means when it will be 1, when the value of y will be 1, when the value of y in more than 0, then the value of y is equal to 1. When the value of y in between the -1 -0 to 0, the value will be 0, and if the value of y less than 0, then the value of y will be -1. So these are the basic activation function. So what is the activation functions? So activation function is y is equal to 1 when y greater than 0, y is equal to 0 when y in between the -0 to 0, and y is equal to -1 when y less than 0. Next, we calculate the weights, the new weights for all the input patterns. Okay, so here we have taken theta is equal to 0 initially. Okay, here we have taken theta is equal to 0 initially. Then we first check what is the value of y. Here t is equal to y means target. So initially t is equal to -1. Why t is equal to -1? If we consider the truth table, that is for the 1 1 combination, the target will be -1. Therefore x1 is equal to 1, x2 is equal to 1, and t is equal to -1 for the first input pattern. Okay. So here we first calculate W1, W2 and B. New W1, W2 and B. Initially the value of W1, W2 and B is what? Initially the value of W1, W2 and B is 0. Now the value of, now we calculate the new value of W1, W2 and B. This is very important. Okay. So what is the formula of calculating the new weight? That is W1 old. What is the W1 old? W1 old means W1 old, that is W1 old, that is 0, W2 old is 0 and B old is 0. Therefore W1 old we replace here 0 plus alpha into t into x1. So what is the value of alpha? We initially treat alpha as 1 and t is the target, that is -1. So we write here -1. And what is the x1 for the first input? That is 1. So what will be the output for the W1 new? That is -1. Similarly we calculate W2 new, that is W2 old, plus alpha into t into x2, that is 0, that is W2 old is 0, plus 1 from, that is x2, x2 is equal to what? X2, that is alpha. Here alpha value is 1 and t value is again -1 and x2 value is 1. Therefore the ultimate output for the W2 is equal to -1. And what is the B new? That is B new is equal to B old plus alpha t. So what is the value of B old? We know B old value is 0 and alpha value is 1 and t value is -1. So -1, -1 and -1 are the new value of the weights. That is the W1 is -1, W2 is -1 and t also and B also -1. So we get this one after the first sample, after the first input sample. So the weights are presenting after the first input sample. That is W is equal to now become -1, -1 and -1. Next, the weight after presenting the first input, first sample or the first input, we calculate the second input sample. So we calculate the first net input. What is y1? That is y1 is equal to b plus x1 w1 plus x2 w2. So what is the value of b now? B is equal to -1. So we write here first -1. And what is the x1? X1. This is very important. What is the x1? Now we go through the truth table. So what is the truth table? Our truth table is in this for the second input pattern, that is 1 -1. Truth table for second input pattern is 1 -1 and t is equal to 1. So here we write. So here we write what is the value of b, that is -1. So what is the value of x1? That is 1 and w1 is equal to, we know from here -1. So we write here -1. And what is x2? That is -1 and what is w2? That is -2. Okay. So ultimately we get the value of y in, that is what, that is equal to -1. Okay. So output of y, that is if y in is equal to -1. Why it is -1? So why the output of y is equal to -1? Because y is equal to -1. So as per the activation function, we know that is y is equal to -1 when y is equal to, when y less than -0. So here the value of y is equal to what? Value of y is equal to -1. Therefore y is equal to -1. So -1 means it is less than -0. So y is equal to -1. So the output y is equal to f of y is obtained by applying the activation function. Hence y is equal to -1. Since t not equals to y, yes, t not equals to y, this is very important. So what is our target and what is our final output? That should be matched. Now it is not matched. Okay. So y is equal to -1. So the new weights are calculated as, so this for the second input pattern. So what is old? That is what is w1 old, w2 old and b old. It is -1, -1 and -1 also. Okay. So this is -1 plus 1 into 1 into 1. We know alpha is equal to 1, t is equal to 1 and x1 also 1. Okay. For the second input pattern, so it will be 0. Next for the w2, we know that is -1, that is w2 old is equal to -1, we know, and this is alpha is equal to 1, t is equal to 1 and x2 is equal to -1. Therefore the value will be -2. And what is the value of b? Similarly the value of b is 0. So the weight after presenting the second sample are that is w is equal to 0 minus 2 0. So for the third input sample, we know x1 is equal to -1, x2 is equal to 1, and t is equal to -1. So what will be the net output? We just input the value of x1, x2, and t in the function yn, and ultimately we get like the same way, like the previous way, that is 0 plus -1 into 0 plus 1 into -2 is equal to 0 plus 0 minus 2, that is equals to -2. Okay, the output is obtained y, that is equals to -1. Why? If the value of y is less than -0, then the value of y will be -1. Since t is equal to y, what t is equal to y, that is now here what is the value of y? What is the value of y? The value of y is equal to -1, and what is our target? That is -1. Our target in the third input pattern, our target is t is equal to -1, and here we also get the value of y, that also -1. So since t is equal to y, so no weight change. If t not equals to y, then weight change. Okay, since t is equal to y, then there will be no question of changing the weights. Thus, even after presenting the third input sample, the weights are, that is what is the value of w new, that is for the third input pattern, that is 0, -2, and 0. Okay, 0, -2, and 0. So similarly for the fourth input sample, that is x1 is equal to -1, x2 is equal to -1, and t is equal to -1. Again we calculate the y, that is b plus x1 w1 plus x2 w2. So what is the value of b? The value of b is equal to 0, and the value of x1 we know, that is -1, and w1 from the previous slides, that is 0. Okay, and what is the value of x2? That is -1, and what is the value of w2? That is the value of that, what is the value of that w2? That is -2 from the previous slides. Like the previous slides, that is, this is the w1, this is w2, and this is p. Okay, so w1 is equal to 0 and w2 is equal to -2. Okay, so ultimately we get the value is 2, and we know that is y is equal to 1 because yn is more than 0. If yn is more than 0, then the value of y will be 1. Since here also t not equals to y, that is new weights are updating at the given, that is t not equals to y. What does it mean? Here the t for the fourth input pattern, t is -1, and what is y? That is 1. So t not equals to 1, so weight will be updated. So what will be the new weight? That is w1 is equal to, we know, w1 plus alpha into t into x1. So we just put the value here, and ultimately we get the value of w new for the fourth input pattern is 1, and for the w2 it will be -1, and for the b it will be -1. So the weights after presenting the fourth input sample are 1, -1, and -1, 1, -1, and -1. Okay, so now we come to the final stage, that is we now calculate the final weights. Okay, using the perceptive network for anode function, which is shown in the figure or table. Fine. So first of all, we write down the inputs, that is x1, x2. Okay, we know 1 -1, 1 -1, 1 1 -1 -1, and initially this is our inputs, that is all cases. This is our bias input, that is here for all the cases it will be 1. And what is our target? That is the output. We know for the AND NOT function, this is important. For the AND NOT function, if it is 1 and -1 combination, then the output or the target will be 1. Otherwise, all are -1. Okay, so up to this, it's fully clear now. Next, we put the value of w2, w1, w2, and b. Initially, w1, w2, and b is 0, and then in the at each and every stage, we calculated the new value of w1, w2, and b. Okay, so after first input pattern, we get after giving the first input pattern, we get the value of w1, w2, and b is -1, -1, -2. In the second part, that is 0, -2, 0. In the third part, no change is there, so it will be 0, -2, 0. Why? Because here t is equal to y, therefore there is no weight change. Okay, if t not equals to y, then there will be the question of weight change. If t is equal to y, then there will be no question of weight change. In the first part, at the fourth part, that will be 1, -1, and -1 for the weights of the new weights. Okay, so now we calculate the y value. What is the value of y? We calculate it in our previous slides. Now we have seen also how to calculate. That is, first what the value of x1 x2 and what is the value of w1 w2, and b here the x1 x2 is 1 1 and w1 w2 is equal to 0 0 and b is equal to 0. So what is the equation for calculating y? That is b plus w1 x1 plus w2 x2. So b is equal to 0. So we multiply 0 with 1, that is 0. We multiply w2, that is 0 with 1, that is 0. So y value will be 0. And if y is equal to 0, then y will, and then the value of y is equal to 0. Okay. Next the new changes value is what? That is minus 1 and minus 1. Next, what is our input what inputs? That is 1 minus 1, and output, that is target, will be 1. So we just multiply minus 1 with 1, that is minus 1. This minus 1 with minus 1, that is 1. So 1 and minus 1 0, and this minus 1, that is minus 1. So if the y is equal to minus 1, then output y will be minus 1 because it is less than minus 0. So it will be minus 1. Again 0 minus to 0, and this will be minus 1 1 and minus 1. So we multiply 0 with minus 1, that is 0. We multiply minus 2 with 1, that is minus 2, and this is 0. So the output will be minus 2, and which is again less than minus 0. So the output will be minus 1. And then 0 minus to 0, and what is our input targets? That is inputs are minus 1 and targets is minus 1. So we multiply 0 with minus 1, that is 0. We multiply minus 2 with minus 1, that is 2. And we multiply 0 with, we multiply minus 1, minus 2 with minus 1, that is 2. And 0 with minus 1, that is 0. And this is 0 simply. So the output become 2, and which is greater than 0. That so the output value of y will be 1. Okay. So this is our output, calculated output, that is 0 minus 1 minus 1 1. This is our net input, that is y in. So 0 minus 1 minus 2 1, and this is our output. So this is the way to calculate the weights, the final weights, using the perception network for the AND function. Thank you all.